Algebra Lesson 4-2. We introduced the idea and the concept of a coordinate plane and ordered pairs last time, so now we're going to try to take that a step further and do more with our graphing. For starters, we've got the idea of a solution of an equation. Now this is interesting because we've solved equations when we played the shuffling game and we've come up with answers. We're actually going to get to a point where we can do the same thing with a graph, find an answer, which means whether we solve the equation with our shuffling game and get an answer, or we solve it with the graph and get an answer, they should produce the exact same answer. They should back each other up. So the solution of an equation is an ordered pair, which we know is x and y, that actually makes the equation true. In other words, when you plug in the value for x and you plug in the value for y into the equation, it works. It'll work in the original equation itself. All right? Graphing an equation is the set of all points, x and y, that are solutions to the equation. So let me give you a really easy equation. Super simple. Say we had y equals x plus 1. Okay? There's a whole bunch of answers that work here, because if you say, well, x could be 2, well then 2 plus 1 is 3, and that means you have an x value of 2 and a y value of 3, so 2, 3 would be considered a solution because it works in this equation. But that's certainly not the only numbers that you could actually add to 1. You could take and go, well, what if x was 4? 4 plus 1 makes 5. That means you have an x value of 4 and a y value of 5. So 4, 5 is also a solution. But that's not the only one. You could say, I could have negative 2 plus 1 makes negative 1. So now there's my x and there's my y, and I've got negative 2, negative 1. That's a solution. In fact, there's so many solutions, I can't possibly put them all up here. So the set is another way of saying a group of all the points that are solutions. We can't possibly write them all down, which is why a graph comes in handy. Because the graph will be a visual representation of all the possibilities without us having to actually come up with all the possibilities. So just remember, there's a whole bunch that could be, we just need some of them. Linear. If you take off the A and the R on linear, produces the word line, straight line. That's what we are going to make with linear. A straight line that's produced from the solutions. If you recall, these were all solutions. They're going to produce a straight line. X and y are the ordered pairs of the equations. So we want to make straight lines, not curves. We don't want anything kind of going like this. We don't want it going really straight and then zogging off. We don't want anything other than a perfectly straight line when we're dealing with linear. So I have some steps for you in order to make sure you graph correctly. Number 1, these are the steps for graphing a linear equation. Remember, a straight line equation. We talked about linear equations. They can't have any absolute values, variables in the absolute value, no variable in the denominator, no variable in a radical, and no exponents other than 1. First of all, do whatever you need to do to write it into function form, which is basically a fancy way of saying do whatever you got to do to get y by itself. I don't care what you have to do, play the shuffling game, but get y alone. It could be that step 1's already done for you. You might not have to actually do much to get y alone, but do whatever it takes to get y alone. Step 2, choose a few values for x. In other words, you get to make up anything you want for x, because remember, you've gotten y alone, so x is probably on the side with everything else, and make an input-output table. Remember, function form of y depends on x, so it'll all matter for what we put in for x. Now, I suggest you at least have 3 points. You want to choose a negative value of x, you want to choose 0, and you want to choose a positive. That way you have an idea of what's happening with this graph on each side of the axes. Step 3, once you've made this input-output table, it creates coordinates. Graph those coordinates and draw a straight line through them. That's your graph. That's all you got to do. All right? When you're making this table, as I mentioned before, use positive and negative numbers and 0 as inputs. You can make 10 inputs if you want, but you got to have a minimum of 3. Make a minimum of 3 is a really good idea. First of all, if you have y equals any number, these are special circumstances. If you have y is equal to any number, you're going to have a horizontal line. What I mean by that is if you see y equals 2 or y equals negative 7, you'll notice there's no x in this at all. You just have y. Then you're going to have a horizontal line that crosses at that number or at that number. If you have just x, meaning no y in it at all, so you have x equals 5 or x equals -9, something like that, then you're going to have a vertical number, a vertical line. These are two special circumstances where the moment you see only x, bam, you know it's vertical. The moment you see only y, you know, bam, it's got to be horizontal. So let's look at that. Here's a situation. You have only y equals 5. We know that whenever we have just a y, it's going to be a horizontal line. So all I have to do is count up 1, 2, 3, 4, 5 and draw a vertical line at 5. That's all I got to do. It has a horizontal line at 5. Given. That's this right there. And if you see just x, if it's just x, then you know you're going to have a vertical line of 4. 1, 2, 3, 4. So there's my vertical line at 4. Those are special circumstances, a little different than the other. All right? Now, if we look quickly at the idea pull out a piece of graph paper so I can graph it. Let's say we had y equals 2x plus 3. Now, according to our steps, step number 1, rewrite it so it's in function form to get y alone. That's really already done. Y is alone. Maybe it didn't look like that, though. Maybe it didn't have y alone. Maybe you saw y minus 3 is equal to 2x. Well, if that's the case, I got to get y alone. So I'll add 3 to both sides. Now I have, those cancel out because it was plus negative, y equals 2x plus 3. Whatever I got to do, I got to get y alone. That's step number 1. So if step 1 is already done for you and y is alone, great. If it's not, play the shuffling game until you get y alone. Step 1. Step number 2, make an input-output table. So inputs for x, outputs for y. I said I need to have 3. One of them's got to be a negative. Make up whatever you want. -2. Got to use 0 and use a positive. You can pick any numbers you want to. It does not matter. Now, if we plug -2 in for x, 2 times -2 is -4. -4 plus a positive 3 will give us -1. Then I plug 0 in for x. 2 times 0 is 0 plus 3 is 3. Then I plug 3 in for x. 2 times 3 is 6, and 6 plus 3 is 9. What you have just created are coordinates. Remember, ordered pairs are x, comma, y. So we just created 3 ordered pairs that I can go over to this and graph. -2, -1. -2, -1. Make sure I'm doing it in the correct order. 0, 3. 0 means I don't go left or right, and I go straight up 3. And 3, 9. 3, 9. If I've done this correctly, it should produce a nice straight line. If I have not done it correctly, then it won't produce a straight line. Sure looks to me like it made a straight line. So I put arrows on it because the arrows actually mean the line continues on forever. But what if I didn't choose these numbers? What if I had chosen 1? Okay, try it out. 2 times 1 is 2, and 2 plus 3 is 5. That means there should be a coordinate at 1, 5. Let's check. If I go over 1 and up 5, 1, 2, 3, 4, sure enough, there's 1, 5. It won't matter what you choose. You can choose any number you want for your input, do the math, and get your output, and you'll create an ordered pair. What if you chose -1? That's okay. 2 times -1 is -2. -2 plus 1 is, -2 plus 3 is +1. So if we plug -1 in, we get +1 out. -1, +1. Boom. It works. There are all kinds. This line right here actually represents every single possible solution. If you recall, we said that the set of all the solutions makes the graph. We can't come up with all the solutions, so we graph some of them, draw the line through them, and the arrow points forever, saying all the answers go forever in both directions. So remember how to make an input-output table and then graph those coordinates. The input-output table creates those coordinates for you. And remember your two special circumstances, just y, no x at all, you're going to be horizontal. If it's just x, no y at all, it's going to be vertical. So you're either going to have vertical, horizontal, or diagonal. If it's diagonal, it'll have both x and y in the problem.